Hello everyone, this is ENCMP 100 Programming Contest Applications Entry by Nathan Power. We're just going to start with a couple of questions that really guided my motivation of this project. Who loves their math class? As long as you ask engineering students, most of them will tell you they do. Now what's the problem with math class? When I ask myself that, the answer is writing in stack notation. In other words, it's the input method for online assignments. We want to write an answer that looks like this. 99% of us would rather write like this in a program like Desmos Scientific Calculator, and not this atrocity that is stack. In particular, writing all the asterisks is a nightmare. That ended up being the spark for the project. In fact, I remembered trying to build the equation in Desmos and paste it into the assignment at the start of the year to see if the formatting would work, which it didn't, but all it meant was I needed a way to go from this to this. Now, starting this project, I didn't know exactly what to expect for all my versions, but I set myself a few guidelines. Version 1 should do something, even if it's simple. No Python functions, basically just replacing strings systematically. That was just to get things going. Version 2 should be where the code starts to come together. Take what you noticed in version 1, factor it, put it into Python functions, and then from there make it so it works for more complicated tests and includes more of the math functions available in Stack. Version 3 was always meant to be the final product, a program I could give to people, they could run, understand how to use, and use it themselves to solve their own stack notation problems. It includes all available functions in Stack, does not break no matter the test case put that is within bounds. Bounds refer to the correct syntax of LaTeX, and only including functions that exist in Stack. Starting with version 1, I was just looking for a way I would be able to start modifying the input. I knew strings were immutable, so I was looking for a way to be able to modify them. Reading some Python documentation, I quickly found the replace function. One more technique I developed that I was using a lot in future versions is redefining a string from its split constituents. Version 2, this is where I hit my biggest block of the whole project. In the versions building up to version 2, I ran into the problem where the functions I derived from version 1 were requiring more and more exceptions and started to become less like a function and more like a giant block of code. No matter how I tried thinking of it differently, I couldn't find a solution. What I did was I opened a blank script and refactored all the functions from version 2 again, and some pieces were taken directly from the version 1.5. But the two very important things that ended up happening was that first, I got a very strong understanding of each piece of my code since I just gone through the entire restructuring process a second time. And secondly, I was able to reimagine the base constructs of the functions, which led to the development of one of the most important functions, the wrapper function. Then moving on to version 3. This is one where everything came together. One of the most apparent changes from version 2 was the user interface system, which you could run, and when you run it, you can type help and get commands, and it also grew the reformulate function a lot as it counted display functions in LaTeX. Lists were replaced with tuples where possible. Comments are used to make the code more readable. Grammar mistakes are corrected, like missing C's and arc stack functions, rigorously tested, where I tried breaking it in as many ways as possible, where the most intense case will be shown right now. It's this 5-ish line LaTeX code. You can take it, copy it into an assignment, and it comes out without any errors. Now, just for some takeaways, this is for anyone who is unsure of how they would complete a project like this themselves that they are passionate about. You don't need to have a full version of a product to start programming. Don't be scared to jump into the projects you don't have any experience with. Starting this project, I didn't even know how I was going to modify the input string from the user inputs because strings are a mutable type. Discovering the replace function and redefining the string based on its constituents were breakthroughs that simply happened because of the process. In fact, I later discovered while watching coding videos on YouTube that redefining a string based off its constituents is a major way Python programmers deal with reformulating strings. Building off of that last point, rely on your documentation. AI is great for many things, but it often won't help you understand the inner workings of how functions operate. Knowing how to search, find, and read documentation is an essential skill that helped me many times when I forgot random pieces of information on Python functions. Finally, when working with complicated problems, the easiest way to deal with them is often to convert as many outline cases as you can to similar cases. The wrapper function that was mentioned in version 2, whose whole process is to do that, became one of the bases of my entire code. Contributions can be found in the code in the help menu, and thank you all.